All right, so let's assume that c is a non-negative real number. That is, that's a number that's 0 or greater. Then the solutions to the equation x squared equal to c are given as x equals plus or minus the square root of c. If c is negative, then this equation has no real solutions. It has imaginary solutions, which we will not get into, but for our purposes, if the c is negative, then it has no real solutions. Again, that symbol, that plus or plus over minus symbol, is read as plus or minus. That means there are two answers, one negative and one positive. So solve x squared equal to 49. So we want to figure out the square root of 49, and the square root of 49 is 7. And if you don't know that, you can always put this in your calculator where you enter 49 and then I hit the square root button, I get 7. So the square root of 49 is 7, which means the solutions are x equals 7 and x equal to negative 7. X squared equal to square root of 10 doesn't have a nice simple number. If I try to put it in the calculator, go 10 square root, I get a decimal that does not terminate or repeat. So this is an irrational number. It goes on forever. You can approximate it at 3.16, but generally it's better to just write x equal to square root of 10 and x equal to negative square root of 10. As for c, part c here, notice that the negative 16 is negative. That means that there are no real solutions, and we'll just leave it at that. If I try to find the square root of negative 16, depending on your calculator, let's try this again. If I go 16 and then turn it negative and then try to find the square root, I get an invalid input. That means it's not a real number. All right, if I have something a little bit more complicated, like x squared minus 12 equals 0, get the x squared by itself first, then try to solve. So for part A, I would add 12 to both sides, and I would have x squared equal to 12. And then the square root property tells me that this is x equal to positive 12 and x equal to negative 12. There's some minor simplifications you can do, which we won't get into. We can just leave it at square root of 12 and negative square root of 12. For part B, subtract 14 from both sides. So I'll have 2x squared equal to negative 14. Divide by 2, and I'll have x squared equal to negative 7. That's negative, so that means there are no real solutions. And if you want to enter this in our WOM app, you can type in DNE. For part C, add 9 to both sides. So we would have 16x squared equal to 9. And then divide by 16. That gives us x squared equal to 9/16. So x is going to equal to the square root of 9 over 16, which the square root of 9 is 3, the square root of 16 is 4. But x is also going to equal to the negative of that. So 3/4 and negative 3/4. Try another one. If an object is dropped from a height of h feet, its distance above the ground at time t is given by h equals 16t squared. So a toy falls 30 feet from a window. How long does the toy take to hit the ground? So basically, we are going ahead and set the distance to 30. We have 30 is equal to h minus 16t squared. Oh, take that back. What we have is the h is 30, so we have 30 minus 16t squared is equal to 0. The distance to the ground will be 0 when at the moment it touches the ground. So we could add 16t squared to both sides. And that gives us 30 is equal to 16t squared. And so divide by 16. And that gives us t squared equal to 30 over 16. And that means that their t is going to be the square root of 30 over 16, or negative. I mean, in this case here, we're not going to deal with the negative answer because we're looking at, we're only going to be looking at positive numbers. We want to figure out how long does it take to hit the ground. That's going to be a positive number. So we're only going to look at one answer here. That's going to be a square root of 30 over 16, but I can also type in 30 divided by 16 and then do the square root. And it looks to be about 1.37. And units here would be seconds. So a little over a second to go 30 feet.